So 3 electrolysis cells are connected in series. They contain respectively solutions of copper to nitrate. So copper to nitrate, remembering that that is copper to nitrate NO3 2. Silver nitrate, so that's just AgNO3. And we have chromium 3 sulfate. So chromium 3 sulfate is chromium 2 SO4 3. Okay, so now let's get to the question. So if 1 gram of copper is electrochemically deposited in the first cell, calculate the mass of silver and chromium deposited in the other cells. So what I'll do here, because we don't have a drawing, I'm going to draw one. Okay, so, all right, let's just put 3 beakers. It's important to get a visual understanding of what's going on. And then we need, so we have the solutions, we know what they are. They contain the ions, the electrolytes. So here we have, in that solution, say we've got copper nitrate electrolyte. In that solution there we have silver nitrate. And in this solution here we have chromium sulfate. Okay, so we've got our solutions. Now we need our electrodes. So our electrodes are the solid sections of this cell, and they deliver electrons. So each of these half cells should have an electrode. So the metals, they need to be conductors of electrons, otherwise it won't work. Now, they're all connected in series. So what is happening is we've got, you know, these 2 electrodes connected to an external battery, and then these electrodes are connected to one another, and then potentially, so this is what series means, and then we have them, we have this connected to an external battery. So some kind of power supply here. So DC power supply. Okay. Now let's have a look at what's going on in terms of the reactions. So we have our, I'll just find the data book. Okay. So if I can just show you a screenshot of this. Now let's have a look at where each of the chemicals are. So we had copper, we had silver. So silver's up here. So silver, as its ion, in its ion state, silver is quite willing to gain electrons and turn into silver solid. Then we have copper, which is slightly worse at gaining electrons than silver is because it's below silver, but it's still pretty good. So copper ions are going to gain electrons and form copper. And then we have chromium. Now you might recognize that chromium, I don't even think it's on this list. No, it's one of those difficult ones that are not on the list. It is a metal, it is a transition metal, but it's not on the list. So I'm going to just go back to our tutorial and just list the ones that we currently have. So we know that silver was at the top, it gained electrons, it became silver solid. We've also got copper. So we have copper ions plus 2 electrons give us copper solid. And we also have the water that we need to consider, because what's happening is that, say, one part of the DC power supply is going to be negative, the other one's going to be positive. So we'll have electrons being accumulated somewhere on this electrode, and then we'll have electrons being taken out of the other electrode. So we have to be very careful with what actually is occurring at those electrodes. So let's read the question. So if 1 gram of copper is electrochemically deposited in the first cell. All right. So you can only have copper forming where you have copper ions present. So because of this, what that basically means is that this reaction here is proceeding forward. Okay, and that's proceeding forward in the very first half cell here. So what you've got on the surface here is you've got a buildup of copper solid. That's just by the copper ions and 2 electrons forming copper solid. So electrons, the direction of electrons, they have to be going that way. They have to be accumulating on the actual electrode here so that you can have the reaction of the following. So copper ions and electrons are going to form copper solid. Okay, so that is the reaction occurring at that location. So that is gaining of electrons, and so it's a reduction. So this is actually the negative, because electrons are being stored here, it's the negative terminal, and in electrolysis it would be referred to as the cathode. Because cathode in electrolysis is where electrons are being deposited so that they can be gained by a particular ion. And that ion, in this case, comes from the copper present in the electrolyte. So you've got that electrode being negative. Now, because this is in series, this electrode here has to be positive. So you must have electrons now flowing that way through this wire here. Okay, so because they're flowing this way, this has to be negative, and then this has to be positive, and then this has to be negative, and then this has to be positive. So it's important to fill in the actual charges of the electrodes, and then we know that electrons must be going that way. So because electrons must be going towards the power supply on this side of the electrolytic cell, this terminal of the battery is actually positive. It's a positive terminal of the battery, and where electrons are getting pushed out of is the negative terminal of your battery. So we know the terminals of the battery and how we would connect that battery in this particular situation. Now, what we have to focus on is we need to focus on all the different reactions that are taking place. So we have electrons being deposited here. I'm just firstly going to work out the reactions that are taking place. So in this case, in this situation, electrons are actually being stored on that electrode there. And so the reaction that takes place is within your solution, you've got silver ions present. Now, if we go back and we look at our electrochemical series, we have to be very careful with where water is positioned, right? Because if water is better, if it happens to be better at gaining electrons than silver ion does, and water is going to be the reaction that takes place. But we can clearly see that silver ions are pretty high up on the electrochemical series, and they're pretty comfortable with gaining electrons. This water equation up here, that one doesn't count, because that water equation there is not gaining electrons. There's no electrons on this side of the chemical reaction. It's only oxygen and hydrogen that are gaining electrons. So oxygen and hydrogen are not in the electrolyte of that half cell. So we have to only consider our silver. So now, what we do, the reaction taking place at that electrode is going to be silver ion plus electron gives us silver solid. So that's the reaction occurring there. And then the last reaction, again, electrons are going to be transferring that way. And they're going to be accumulating on this electrode. So finally, at that location there, we'll have the other, the chromium ions grabbing 3 electrons from that electrode and forming chromium solid. And so those are the half equations of the metals. So you'll have essentially what you'll have going on here is on this half cell here, on this electrode here, you'll start having silver being formed. So you'll find that silver is plated on that. Then on this particular electrode, you have chromium growing off it over a period of time. And we can calculate that time because we have the equations, that Faraday's equations and everything. So we need to calculate those particular masses that are deposited. Now, I'm kind of going off tangent here, but I want to explain what's happening at these positive electrodes, because you might want to know that. Now, the negative electrodes are where electrons are being stored. And so they're being accumulated, and we must have something, an ion that grabs those electrons and removes them off the electrode. So as you can see here, copper ion, which is found within the electrolyte, which is the solution. So the electrolyte is copper nitrate. So you have copper ions in that electrolyte, and they are going to be grabbing the electrons off the electrode, and they're going to be forming copper solid. Okay? Same thing here. Silver ions are going to be grabbing electrons and forming silver solid. And finally, on this one here, chromium ions are going to be grabbing 3 electrons and producing chromium solid. Now, what's happening at the positive terminal is this is where electrons are being given away. Okay? Because if you have a look here, silver is somehow, it has electrons being deposited onto that electrode. So they came from this particular electrode right here. That's where they came from. And so if we check on our electrochemical series, we check what's going to be losing electrons, we have to go all the way down to the water equation. Where is it? No, it's actually all the way up. Yeah. So this, because there's water in that electrolyte solution that I showed you, this water equation here, this half cell, water can actually break into oxygen, hydrogen ions, and electrons. And so that's the reaction that's going to take place at each and every one of those anodes, as I showed you before. So it's going to be water. So if you have a look, water is going to break down into, so 2 waters are going to break down into 4 hydrogen ions, an oxygen, and 4 electrons. And so those 4 electrons are actually going to be transferred to this electrode, and so forth, transferred to this one. So this is the reaction that's taking place in every single one of those positive anodes. Now, getting back to the actual question and what the question is asking us to do. So we have to calculate the mass of silver and chromium deposited in the other cells. So we know that 1 gram of copper is deposited in the first cell. So that can be quite helpful, and the reason for that, so 1 gram of copper solid is made in first half cell. So what we know is that we have copper 2+ plus 2 electrons gives us copper solid. This is our reaction, and we have 1 gram of this being formed. Now, what we can do from that is we can actually, from the copper, find out how much mole of electrons is required. So we've got the mass of copper, which is 1 gram. We also can calculate, well, we know the molar mass of copper, which is 63.5 grams per mole. Now, using that information there, we can work out the mole of copper that is being deposited. So I'll just calculate that. 1 divided by 63.5. So that's 0.015748 mole. So that's the mole of copper, solid. Now, to find the mole of electrons, it's really important to actually find this mole, because if you don't, you won't know how many Faradays are passing through the system. So we have to calculate the mole of electrons. It's quite important, this step. So we know that the mole of electrons is, just use stoichiometry, it's double the mole of, we have to double the mole of copper that is present. So we go 2 times by 0.015748, and that gives us 0.03149606 mole. So that's the mole of electrons. Now, once we have the mole of electrons, we can actually calculate the mass of silver deposited. And the reason why is because this mole of electrons is the mole of electrons, the Faradays that are actually passing through the entire system. So because this is connected in series, at every half cell, you're going to have the same mole of electrons passing. So to calculate the mass of silver, we need to first write out our half equation. We know how much mole of electrons we have from this calculation here. Now, just because there's a different factor in front, it doesn't change the mole of electrons passing through the system. So all we have to do now is we say, okay, well, the mole of silver is equivalent to the mole of electrons that are passing through. So the mole of silver is equal to 0.03149606 mole. And then we have to just calculate the molar mass of silver, which is 107.9 gram per mole. And then we work out the mass of silver. So times by 107.9. 3.0 3984 grams. And of course, we need to convert that into the appropriate significant figures. So just have a look at, that's 3 significant figures. So 3 significant figures, cuts it off there, and we have 3.40 grams to 3 sig figs. Okay, so that's calculating the mass of silver. Now, we also need to calculate the mass of chromium. And because chromium has a different equation, we need to consider this one. So chromium has a 3+ charge, so 3 electrons are required to bring it to neutral state. And so the mole of electrons is still going to be the same. But when we're trying to work out from the mole of electrons the chromium mass, we now have to times by what we want, which is 1. So we times the mole of electrons by 1 divided by 3. 3 is what we don't want. Okay, so that's the factor that we multiply by. So the mole of chromium is equal to 1/3 times by the mole of electrons. So 1/3 times by 0.03149606 mole. So I'll just calculate what that is. 3149606 times by, divided by 3. Okay. So that is 0.01049866 mole. Okay, and what we can do from that information is we can now work out the mass of chromium by taking the mole of chromium and timesing it by the mole of chromium by timesing it by the molar mass of chromium. Okay, so we know what the mole of chromium is. So forth, times by 52. Okay, so times it by 52, and we get a lot less mass deposited, 0.5459 grams, and 3 significant figures is approximately going to be 0.546 grams, correct to 3 significant figures. Now, as you can see, there's a few differences between why the mass of silver was higher than the mass of chromium. Obviously, there's a difference in molar mass. So 1 mole of silver weighs differently than 1 mole of chromium does. However, there's also that concept that there are 3 moles of electrons required before you can actually get 1 mole of chromium out. So there's a lot more mole investment than how much mass you're going to produce. So that's essentially how you calculate the mass of metal deposited at each electrode.